All right. This video is going to show you how to get uh, from point A and point B to shoot remote locations and get a difference in height, difference in uh, horizontal distance, slope. We call it slope, vertical, and horizontal distances. So SHV, right? And you want to get, so that would be this. This would be the difference in height, vertical distance, horizontal distance, and slope distance. But you can get that using a Theodolite. If you have a total station, there's a menu for it. I don't even remember what it's called. Uh, it's been a lot of years since I used a total station. Let's see. So you have a baseline. There's your baseline, 223 feet. That's what this is. It was just a check to make sure all this was working. That baseline was 223. There's coordinates here, so you can get the coordinates, put the coordinates in, it'll get you it'll actually transform the orientation and give you coordinates of the new points, right? These points up here in coordinates. It's so you set up on point A, you take okay, so you set up on point A, and in this case, you're going to set up horizontal angle left. I would set it up horizontal angle left. That way you come back and you hit full angles instead of minus 360. So set up on point A, set it up horizontal angle left. You collimate point 2, rotate it to line your baseline, and that's going to give you a horizontal angle BA2, actually BP point 2 AB. And then the same thing here, you're going to go in and collimate point A and turn, and it's going to give you a horizontal angle. And those are those two horizontal angles there, right? 86 and 47. All right, that's what these are. If I can zoom in like that. Well, you know what I can do? Something better than that. Go right here. So collimate point A, or point 1, 86, and point B, 47. That's those two in red. And then you get your 59 and 109. That's the same here. 59 and 109. So you're going angle left, horizontal angle left, horizontal angle left. All right, now you're collimated on point 2. And then you're going to take a vertical angle reading. In this case, I would shoot point 2 and then point 1, but in order. And then, so that's those two angles there. 12 degrees on point 2 and 14 degrees on point 1. 12 degrees on point 2 and 14 degrees on point 1. All right. And so now you're going to use 108. So now you have these two interior angles. Let's go back to another one. I have this right here. This is the orientation is north. If you look at this one here, the orientation is north going to the right to the left. All right. And then let's see. So this is north up, right? And then we have, so it's going to use, here's how you get the law. So we got to calculate these lengths, right? We have a distance here. This is the baseline, 123. And then you have to calculate these two angles here. So you take this angle from this triangle here, and this angle from the other location, 59, 52, these two angles, right? And then you just take 180 minus those two angles and you get 34. And over here it's 47 and 109, and then you get 22. All right, so that's how you calculate those. And then, so the 34 and 22, and then using the law of sines, you're going to get 398, 19. I'll show you how to get that. So go to Tools Calculator. Formula is different in Excel, but it'd be a 223.682 divided by the sine of 3417 4.1767, close parenthesis, enter. Got to give that 398.18 or I put 1899. But different 19. So I'm not sure why I got a little difference there, but that's the law of sines. That's your that's what you're going to get, right? And you're going to do the same thing over here with this one. You're going to go 223 to divided by the sine of 22,773.37, right? That's what this is, right? And if you look at there, B2, which is the baseline, divided by sine, and here you have to say sine radians of B11. B11 is 22.7736, okay? So that's how you get those two numbers. Those are kind of like let me highlight those. Those are your, that's the ratio, right? So let's do that. I put in not the fill. I just wanted to write the text in blue. All right, so now the horizontal distances, you're going to calculate these horizontal distances, and then I'll show you how to do that. So that equation, this one here, Control C. So you end up with P, the 223.682 divided by the sine of, and we're going to use the other angle here, 59.5202, 59.5202, sine of it by the sine of that. So to the baseline divided by the sine of that angle, and the baseline divided by the sine of this angle equals, this is the baseline, this is the x. The x is the unknown, so we don't know the length. Divided by the sine of that angle will equal, and that's that same number, 398.1899. I think I did something wrong in the calculation there, so it'd be copy. Control V. This calculator doesn't run out to the 15 decimal places, unless in the first time it'll round up good. Let's see, if you try to use something that you've calculated before, it's only rounded up to the 4th decimal place. So now you have x divided by the sine of that is equal to this. Let me just type that, Control C, in case you're new. Enter. So what we're going to do is we're going to take that, the x, so let me just do this, Control C, go back here, Control V, and then x is equal to the sine of this times that, right? So we get rid of that, x, multiply, and then get rid of that, delete. So copy, Control C, compute, Control V equals Control C and Control V. And that'll show you, that just shows you how to get that distance right there. So the sine of this angle is this distance divided by the sine of that is going to have the same ratio as this distance divided by the sine of that. And then that's how you 343.16. So that's how you calculate that length using a theodolite. That's the horizontal distance, right? And we don't care about the vertical distances here, so we're not worried about height of the instrument or anything. So let's go back to here. And then that's how you calculate that length. And honestly, I don't even know if that length, yeah, it is critical. You need that length if you're going to calculate the coordinates, right? And then let's see. So those are the same. That's the same. Those are calculating the horizontal lengths, right? 55, 54. Angle P2, horizontal distance A to P2. I think that's horizontal distance A to P2, since it's in horizontal distance. 554, 544.055. So those what's going on with those calculations there. You'll start to get little errors because the right here, these are all these distances are rounded, and all the angles are to 4 decimal places. If you went out further, you'd get more accurate, but that's about 4 decimal places is a good baseline for. I don't know what the difference is in seconds, but it's pretty darn close. Maybe it's a couple seconds. Let's go back to here. So then now you're going to calculate the height. So P1, the height above B for P1. So you're going to look at that. You're going to need that horizontal distance right here, 397. The horizontal distance. Yeah. And you're going to need that 14 degrees, right? So if you type in the height above, you're going to go tangent radians. So it's basically, you have the degrees, you're going to get the tangent of that degrees, multiply it by B14, which is the degrees 14.8338, right? That degrees right there. All right, let's go back and here, turn on this window. All right, now you're starting to look at the 3D. So there's that horizontal distance, and it's just calculated with the 1438. We're looking at this above the instrument, this distance right here. Maybe said it was 109. Oh, it's 105. So I think that's taken into account the height of instrument. 105. Oh, I thought I said 109. So 105. Yeah, so there's you go. That's your vertical, that's the horizontal, that's the distance above the instrument. And above B, it's actually, it would be above, I don't know if there's anything related to this. And then same thing here, and whatever, those are just the difference above the instrument, right? And then difference in height from HB at A, 50. Honestly, oh, this is angle. So this is so I don't know what these are used for, but yet whatever it did, I added the 5 foot because there's a 5 foot height of instrument right here that you input. This is the degrees right here. The horizontal difference between the two. Let's go to window, plan. That's this angle right here, Alt MA. $50.17. So this is calculated right there. That's just the horizontal angles. That's just this. This angle, 109 minus 50.17. And that'll give you, I know, let's see. Yeah, these two. So 109 minus 59 gives you the 50. So that's this angle here. And what you're going to do, you're going to use that angle to get this rise. So you're going to go this distance here, this 397. So it'd be, I'm not sure how I did it. Probably since it's an angle, it's going to be this distance. And we're looking for this distance right here. Actually, I'm looking for this one. I think I did an extra step. So it would be, so it would be, I'm looking for this distance, right? So x over 397.36 is equal to cosine of 50.17. All right. So they're going to take cosine of 50 times 397. Let's go back here. So I could do that here just to see where it went wrong. Equals 397 times cosine of this, cosine radians, open parenthesis, hit that, double close, enter, 254. So this one here, I just did a bunch of other extra stuff. I did it by square root of this minus, I don't know how I got it, to tell you the truth. Oh, so yeah, I calculated this, probably using the sine of that angle. Did this over this as a sine, and then got that, and then used the, did some extra steps in there. All right, but anyways, that's the number you're looking for, this number right here. This distance, right, 254. And then you're going to take this one, since you calculated using law of sines, 426 minus that, it's going to give you the 171. That's that number there. And then I think you have what you need to calculate the distance. So let's go vertical distance from P1 to P2. And then we calculated the heights. That's why there was no need to calculate in the height of instrument, right? It was just for the difference in heights. All right, so the difference in heights there, that's how you get that 9 foot horizontal distance, square root of this. So this is this distance right here, so horizontal distance. This distance here, so we'll have this and this. So I use this distance 305 squared plus this distance here squared, square root of that. And let's see if that looks familiar. Yeah, square root of this plus that. Yep, that was the square root of 305 and 171. These two. And then here's your coordinates. You're inputting these coordinates right here. This is actual coordinates of the point. And then this is, so right here, right? Let's see. Oh, so in this one, it's going to add. Okay, so coordinates of point A. This is your hub, though, not the instrument, right? And then coordinates of point B, and the same thing, just 2 base points. And then you're going to do the azimuth, so this just takes these two and gets the arctangent of this minus the y squared minus the y squared, y1 minus y2 divided by y2, x2 minus y2, rise divided by run, gives you that angle, right? And it's orientation that's positive, so I think it's -1 times that, get it in the right direction. This is mathematical, and then you get the geographical. And then P1. So then, honestly, I'm starting to lose track, but cosine, radians. Yeah, so what it's doing is getting, yeah, so I'll show you real quick. Right here, it's pretty good having this one here. So it's rotating this, right? So that this is orientated to the north, right? And then it's basically transforming this orientation. So what I did was, there's that 18.58 degrees. There's that, right? So then you take, this is what it's going to use, that coordinate and this angle and this distance, because the distance doesn't change in the transform, right? This 397, and then it'll calculate the, anyway, there's the formula. And it's using the cosine. This one's using the sine of that angle, same distance probably, right? And then here's your z coordinate. There's, it's adding in the 5 feet for the, because all those angles and everything's coming off without a height of instrument, but this here adds the height of instrument. All right, so it's taking that original, adding it to the 105 that was higher than, and then adding the 5 foot. And then this is exactly the same thing for coordinates. Point B, there's no need for, height of instrument on B, obviously. And this was setting up on A and going to B, so all the shots are actually taken to B from B. And I hope that helps you understand. And I think that's about it. It hasn't been checked. I just did it and it worked. Modified it a few times to get everything. This was probably the trickier bit, doing the transform. So I don't know if that's ever going to come up in your career, but if it does, I hope that helps you make some money and increase the value of your work. Thanks for watching. Have a great day.